Recording! Y'all are live! Not really live. Anyways, we just finished this problem up. We're going to start this one right here. Let me remind you the formula that we're going to use again and again and again for all this stuff is that our probability is equal to selected over total. So we're just going to see that again and again and again and again and again and again all the time. So here we go. We're back to cards. Y'all know cards? Y'all like cards, don't you? So we got 52 card deck, and it says, what's the probability of a queen or a two? All right, guys, I have a question. Do you want me to scroll back up to the cards? Can I do that? Y'all okay with that? I'm going to scroll back up to where the cards are. It's not right there. It's like earlier. Right. Wait, right there, right there. So what was the question again? Queen or a two? I'm going to select all of my queens. And then 4 twos, exactly. So how many got selected? How many got selected? How many? 8 out of 52. You got it. Here we go. Back I go. So yeah, for this one, I'm gonna say queen or a two because like I have more room right here. So I had 8 selected out of 52 total. Do y'all know what that comes to? I don't know. I'm just gonna put it in a calculator. There we go. 2 out of 13. Or again, if they want the decimal, you can get the decimal. Is that okay so far? Pretty easy, right? So the next one says a queen or a two or a three. Can you guess how many selected this time? 12. Exactly. 12 are selected out of our 52 total. And what would the fraction be now? Calculator. Very good. Okay. It's 3 out of 13. There you go. Like I know this is a pretty basic class here. We don't need to go and try to reduce our fractions or something. Just let the calculator do it for you. The last one's a little different. It says a queen or no, it doesn't say a queen. It says an ace or a club. So an ace or a club. Now, I'm not going to ask y'all what you think. An ace or a club. Right here, the last one. Yep, so let's go check it out. I want to go look at it and circle things. So here we go. Ace or a club. I'm going to circle all my aces, and I'm going to circle all my clubs. Now, hold on. Don't I have the ace of clubs? Do I count him twice? No. You only count him once. So basically, I want to just add up all the numbers that I got. So, yep, 13 for this one, and then 1, 2, and 3. So it'd be 13 plus 3 more is 16 selected. Yeah, 16 selected. Are y'all cool with that so far? Out of 52. There it is. And you're done. There's the whole problem. You're done. Yep. So then I had 16 selected. 52 total. Calculator. Go ahead. So 4 out of 13. And there we go. Right. Let's go back up. Yeah. Right. I just wanted, so I select all my aces and I select all my clubs. And I'm like counting, how many did I actually circle? You know what I mean? So then I count 1, 2, 3, 4, 5, 6, 13, 14, 15, 16. Cool? Again, because we're not counting anybody twice. Very good. Okay, so we're done scrolling. I don't have to do that anymore. Any questions on cards? No? Okay, awesome. So we're going to keep cruising. Let's do this one. All right, so it says, what's the probability between 30 and 39? 30 to 39. That would be these folks right here, yeah? See, that's 30 to 34, 35 to 39. So these folks right there. What would I do with these two folks right here, these two percentages? You add them up. You got it. So I got 37.5 plus the 24.5. Add them up, and there we go. We're done. Perfect. 62%. Now, they're saying round to the nearest thousand, blah, 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 blah. What do they mean by that? Like, what do I actually put into MyMathLab? The decimal 62. Yep, exactly. Yep, the decimal. And it says like thousandth place or whatever. Yeah, 0, whatever. Yep, correct. Correct. Yeah, you got it. You got it. So let's keep going. It says not those folks. So isn't that the opposite? We were asking for this. Now we're on the opposite. The opposite. How would I get the opposite of 62? What's the opposite of 62? What do we do to get the opposite? Yeah, subtract. Yeah, and you got it exactly. 100% minus the 62 gets us what? 30? Is it 38? Let me check here. Yeah, I'm just triple checking, but you're right. Yep, 38%. Again, they want nearest thousandth, so we're just going to use the decimals. What they're trying to say there. So go ahead. When they yeah, there's a 0. Yeah, exactly. And they're just here. We only got the 2 decimals, so the thousandth would be a 0. That's correct. All right, less than 45. I'm gonna start switching my colors. Less than 45. So that would be, whoa, that would be all of these people right here, wouldn't it? What do I do with all those numbers? Add them all up. Here we go. And I know it's a little bit slow, but I am going exactly with like the selected over total. I'm literally just selecting them. What's the total percentage, you think? I am recording. I am. Thank you for double checking. Oh yeah, definitely. Yep. We're I am recording. Definitely. What's the total percentage? Like if I added all these guys up, what should I get here? Exactly. So what I'm actually doing is all these numbers here divided by 100 essentially. But like, that yeah, go ahead. Perfect. That's exactly what they're wanting you to do, but Chad's the slow person here. I'll show you in a second. There's a faster way to do it, which is totally fine. I'm just recommending to you. I'm recommending the easiest method that you. Yeah, exactly. That's exactly right. 0.963. So there's your 3 decimals. And so yeah, a quicker way is saying, oh well, the 3 is not included. So I could just instead do 100% minus that 3.7%, and then I would get it. Same answer, right? You don't have to do it that way. It's up to you. It is easier, but you also have to think about like, what am I doing there? Last one, it says at least 20. What does it mean to be at least 20? Does it mean like 18-year-olds, 17-year-olds? Is that at least 20? No. What are they trying to say is 20 or more, right? At least 20. So 20, 21, 22, 23, that kind of thing. You see the language here is kind of just vague, but I'm trying to make sure you see it, right? They're saying 20 or more. So that would be like all of these people right here, like all of these, including these. I didn't even circle them right. Here we go again, 6.2, adding all these numbers up together. 20, and at this point, I've totally messed it all up. It doesn't look good. Or, you got it? Go ahead, say it. Yes, yes. That's what they're trying to say. So that is an option here. Could one of y'all yeah, is that okay? Thank you. Um so yeah, I know I'm definitely going the slow way, but I'm also trying to just do it the way that's yeah, the quickest I mean not the quickest, the simplest way I can remember. Okay. Is that cool? Any questions? I'm here for you if you got questions. Right there. I just converted it to decimal form. 986. Yeah. It's going to let me zoom in a little. Okay. Cool? Good? Keep cruising? I'm going to keep cruising. All right, cool. So we have a big table. It says, what's the probability of type B or type AB? So if I'm looking around, I want all the type Bs. How many type Bs do we got? 45. How many ABs? Boom. And what do I do to those two numbers? You add them up. So what you're finding here is that the OR means to add. And when I say the word and, we're supposed to, do you remember? Multiply. And means multiply. I know it's been a long time. The 409 is my total. I know it's been a long time since we did this because, well, it's been a while. But here we are. 149. You got it. It's like 14 or 15%. So far, so good. Use brown for a second here. So it says find the probability of O or positive. So I'm going to select all my O's. I'm going to select all my positives. Could you have O positive? Is that a possibility? Yeah, right there. There's O positives as well, right? So I just want to know who got selected. Notice that these totals are going to be a little hard to work with. I'd rather just select my actual data in this case. So I need to find out how many got selected. So 28 to 156, 139. Am I going to count these guys twice? No, never count anybody twice. Never, just never. If anybody says, should we count these people twice? The answer is no, ever. Are y'all seeing how I'm adding them all up? I'm adding all the O's and then the positives. Yep, so anybody that was an O, anybody that was a positive. You could use the totals a little bit, but I don't want to duplicate. Oh, I don't know. It's blood stuff. I don't know. I'm not a blood person. I don't know. Go ahead. O's or positives. There we go. Cool? Cool? Is that okay, guys? Again, don't count anybody twice. You don't have to use the totals. You can just kind of look at them, okay? I'm just showing you different techniques. So like what I used to recommend, and I maybe still do, when you're taking your exam, what you could do is use your number 2 pencil and draw on the monitor to circle in. Oh, I know, that would be bad. Don't let Amanda see you do that. But it's number 2 pencil. It'll erase. They said all the B's and the AB's. Those I could just look at the totals and they're pretty fast. I added them up. Yeah. Yeah, that was it. My total, the 409. No. No, everything's being added. See, there's my total. You can move on up. Okay. Okay. Yeah, yeah. 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 Yep, divided by. Selected over total. You got it. Yep. So these guys right here, these last ones, I gotta say are a little bit weird. And some of y'all have had algebra recently, and it's not a big deal. But I gotta show you like a formula on what they're asking for. So I'm gonna go back up for a second. There's this formula that we had talked about like a long time ago. It's now almost been 2 weeks. But essentially, OR means add. But more specifically, we have to remove the counting twice stuff. You don't want to count anybody twice. So let me remind you of these formulas. That's what it means. Yeah, that you don't want to count them twice. So let me just go back through the formula. This is the Chad formula. OR is equal to the A plus the B minus the and. That's the Chad formula. Very quick. It's very straightforward. I'm going to just toss things in and see what we get, okay? So if I look here, we got 3 numbers, and they're looking for the and. Let me toss them in. So my or, what would I put for the or? What's my number for or? 6, 7. You got it. What's my A number? 0.5. B is? Perfect. Thank you. And then I don't know what and is, but that's the thing we're trying to solve for, right? And now we have to do a little bit of it. Yeah, we have to do a little bit of algebra. Just the tiniest amount, though. Really, it's going to be so tiny. So, like, first off, I'm going to combine like terms. I know that this is like old school stuff, maybe. So 5 and 3 make an 8. And I need to get and by itself. Okay. So what I could do, what would you do actually? Algebra folks. Subtract the 80, you said, or which one? Subtract this one? The 80. Yep, perfect. Let's subtract the 80. I like it. Very good, very good. And they cancel out. And so right here, that's a calculator thing. I don't know what that is. So I got a 0.67 minus the 0.8. I got a negative 13 is equal to a negative and. So what do you think and's equal to? Exactly. Yep. And we're going to only have positive numbers in this class anyways when it comes to this stuff. So yeah, there you go. There's another way to do this. If you want a separate formula that just gets you the answer, you can also use and is equal to A plus B minus the or. So that's also a fine formula, and that would work immediately. Hello. Cool. Are y'all okay kind of doing a little bit of, I mean the little bit of algebra, tiny algebra? Yeah? Okay. Just kind of showing you like it's show and tell algebra. So very similar here. It says find B. Well, let me go back to my formulas. I got or is equal to A plus B minus the and. What would I put for or? Looking at my numbers, what would I put for or? Yep, 98 is equal to, my A is A. Perfect. B, I don't know what B is, but and. Perfect. Thank you. See, I'm trying to keep it as just basic and simple as possible. Like when it says or, you put or. You don't need all that P stuff. You don't need to complicate it. You get what I'm trying to say there? Straightforward, as easy as possible. So I'm going to start moving things over. I'm going to subtract the 60 to the other side. And then I'm going to add this 2 to the other side. And so then I should get that all together here. 98 minus the 60 plus the 02. So there we go. B is equal to 40. Yeah. You're in pre-cal. This should be fine for you. Thanks. I'm here for you. I'm trying to show you like you can use these formulas or you can do, different formulas. It's up to you. What do you think? Is this okay? Okay. I'm trying to keep it as simple as possible. Whenever it says right here B complement, that little C means complement, which also means opposite. Yes, exactly. So if my regular B was 40%, what's my B complement, my B prime? What's the opposite? What's the opposite of 40% is? Perfect. Yep. And all I did there was 1 minus. I said 1 minus that amount to get this amount. I could do that in the calculator even. There we go. Cool? I know that was a little bit of math, but I mean, we're going to move on to better stuff. Is it? I'm here for you. Any questions right now? Tell me. No? Okay. I'm going to start a new section then, okay? And it's definitely going to be better than what this little stuff is right here. Of course, there's first off a lot of definitions. So let me get through that, and then we're going to keep cruising into fun stuff here. Okay. 5, 4, 3, 2, 1. Here we go. Bloop. All right, independent. So let me go ahead and fill these guys in here, okay? This box, independent, and this one is dependent, okay? And I'm going to give you, there's another name. Oh my gosh. So they don't have it in the workbook, but I've got to give you the word here, okay? It's called disjoint. Disjoint. And it means no common outcomes. So we're going to use that later. I think that came up on the homework. No common outcomes. So, okay. I also have a note here. Let me just real quick write it. I'll talk about all this stuff. Just give me one last second here, okay? Not necessarily independent. Okay, so let me re-say it, okay? Disjoint means no common outcomes, not necessarily independent. Okay, that's what my words say. And then here I just got independent, dependent. So what is independent and dependent? Independent is when two events they don't affect one another. See, it does not affect the other one. So here's some examples. Let's go through some examples. Okay, we're sitting here in class, and let's just say we might get out early. That would be pretty cool, right? That's pretty awesome. But okay, what's the probability of getting out early, etc., blah, blah, blah. But hey, just letting you know, the chemistry class over there, they're going to stay late. What is the chemistry class over there have got to do anything with us over here? Nothing. They don't affect one another. Does that make sense there? Okay. On the weekends, I'm listening to music. Yeah? And during the weekend, you are watching a movie. Do they affect one another? No. Okay. Let me try something else, though. During the weekend, I send out an announcement, and I say, I'm going to change the due date. And then you're going to do some homework. Did I affect that a little bit? Yeah, I'm not going to do that. I'm just joking with you. But but you can see independent, dependent, if they affect or they don't affect one another. Okay, so these I'm going to have you tell me if they're independent or dependent, okay? So you flip a coin and you roll a dice. Like, they don't even want to know what the answer is. They just say, is it independent or dependent? Flip a coin, roll a dice. Independent or dependent? Say it. Independent. Independent. Because you flip a coin, you roll a dice, they're totally separate. They're not going to change one another at all. Earning a degree, earning a lot of money. Are they independent or dependent? Dependent. Dependent. It is debatable. It is debatable. I thought about it too. Hello. Yeah, it is debatable. Because I don't make that much. Not even close. Just telling you. You want to be a teacher, huh? Is that what you're thinking? No? There it is then, okay? You can go make more money than me. Okay. We got two 24-year-old drivers who live in the United States, and it says the event, one person gets in a car accident during the 1 year, two people in a car accident during the year. You got two people just randomly in the United States. Do they affect one another? No, independent. Okay. This is where I have got to do my own little thing here. So kind of give me some Chad space here. Here we go. You ready? So again, whenever you see the word and, they mean to multiply. And anytime you see the word or, they mean to add. Just keep that in mind. And so they say right here, independent, what would it be? It's basically multiply. So all we're doing is multiplying. That's all. That's the big lesson today. What do we do here in this section, Chad? You multiply. Yep. So let's do it. It says you flip a coin, you roll a dice. What's the probability of heads? And what does and mean again? Multiply, rolling a 5. Okay, so obtaining a heads on a coin. I got heads, I got tails. Exactly. Heads is 1 selected out of 2 total. Is that cool so far? And means multiply, rolling a 5. So I got 1, 2, 3, 4, 5, 6. Right, I got 1 selected out of 6 total. And what am I supposed to do with these 2 numbers here? Boom, calculator time. Here we go. 1/2 times 1/6. And I think they're going to want fractions anyways. Is that okay? Are we cool with that? Any questions? I love multiplying. Do you love multiplying? In the calculator? You wouldn't want to do that for reals, right? That's all it is. You got the whole lesson right there. Okay, game of roulette. We got numbers 0, 0, 0, and then 1, 2, 3, 4, all the way to 36. And so you're throwing the metal ball around, and it's going to fall in one of the slots. It says, what's the probability that the numbered slot 21 2 times in a row? All right, so what we have here is 0, 0, 0, 1, 2, 3, da 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 da, 21, da 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 da, then all the way to 36. Right? So I'm selecting how many? 1 selected. My roulette starts with 0, 0, 0, 1, 2, 3, all the way to 36. So I'm selecting, it says select 21 twice in a row. So I got 1 selected. What's my total here? 30, not 6, 38. Didn't draw that very well. 38 total. Now, so that was just one time. That was just one time. And then I do it again. So what? I roll the ball again, and it's supposed to hit 21. So what's my selected? 1. What's my total again? You got it. I didn't spell selected very well, but you got it. There you go. 1 out of 38. See you later. So I got 1 out of 38, and then I got 1 out of 38. Whoa, 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 Chad! What'd you just do on me, bro? How you do me like that, man? Do you see what that is? What is that? What do you call that thing? Scientific notation? Is that something we need to do in this class? Just a tiny bit. Just a tiny bit. So what they mean by this, and I'm gonna do it here on the side. What they mean by this is 0006925. Essentially, you see that little -4? So what we're going to do is 3 zeros and then start the number. That's kind of what they're going with. So I'm going to rewrite what I had, 6.925 times 10 to the -4. So how I remember it is there's 3 zeros and then you start the number. Or you could just move the decimal place 4 times, right? Are y'all okay with both of those? Yeah. Yeah, I did it right here. 1 over 38. Then oh no, I literally just typed it out. 1 out of 38, 1 out of 38, and it just showed me this thing. No, I didn't click anything else. No, I mean you could do the fraction action. I guess that's something. I don't know if they want that or not. But yeah, that's just I just typed it. It just happened. Yeah. Is that okay? We're cool? So, would you stake all your money on something like that? Nope, because like that's pretty low probability of happening. Okay. All right, cool. Keep cruising then. Keep cruising. So it says probability of a 24-year-old will survive is 99.86%. Okay, now that's kind of weird, right? Hey, what's the probability you live in this year? Right? It's kind of like an odd question, right? So it says, what is the probability of 3 randomly selected people will survive this year? Let's think about this for a second, okay? So I've got a whole bunch of folks all lined up. So far, so good. And then I'm going to say, what's the probability of you surviving? And you're surviving. And you're surviving. I used and, didn't I? It says all 3. I need this one to survive, and this person, and means to multiply. So then what I'm going to do is 9986 times the 9986 times the 9986. There it is. There it is. I'm going to do that in just a second. You got it. 9986. So we can do that, but like you said, I can also do the power and see how I could do like a power 3. It makes it faster, but again, will you remember that on a test? That's the biggest question there. So there's your final answer. And it's kind of weird. You got 9986, 9986, 9986, and your answer is 9958. It didn't really change much. That's fine. It happens. It's just what it is. Okay. So it says if we select 100 different people, then what's the probability of all 3 of these? Basically, I'm just going to do it 1,000 times here. Did I say 100? I meant 1,000. So I'm going to say my answer, ANS times 1,000. That's a quick way to do it. Or again, you could just type out whatever that number was. So 9958 times 1,000. So 900, what would that be if I had to have actual people? 996. There you go. So all I did was just multiply. 9958 times 1,000 to get that number right there. Oops. Cool? Multiply? We're cool with multiply? Cool. It says, what's the probability that 20 will survive? So now I got the 9986, 9986, 9986, 9986, 9986, Couldn't I just do that power thingy? Wouldn't that be way better if I could just do this? And so that makes it a lot faster. I mean, we're multiplying. It's just that we're multiplying like 20 different things, and that would take forever. So here we go. 9724. And then again, it says times 1,000. You can already guess what that's going to be. 972 rounded, I guess. Are y'all okay using the power thing? Have y'all seen that before, right? To the 20th power. That's right. To the 20th power. It just makes it a lot faster. All right, let's talk about this at least one thing because it is very important. It's going to come up on your homework a lot. Like I have a special thing in my notes here for this one, okay? This is not for me to fill in. It's more of like a formula thingy. So let me show you what I'm going to do here. 1 minus the 9986 to the 500 power is equal to, and I'm going to find it here in a second. So read this real quick. It says, what's the probability of at least 1 out of 500? And if you have this situation, normally like, 20 or 3 or 500, it's all good. You just put the power in, but now it says at least 1. So you just do this 1 minus the amount. It's trying to say the opposite. 9886. And I know 500 is like crazy, but there you go. 5037, I guess. I'm just going to write a little thing here. It basically means the opposite, which we've seen before. Is that what I just did? Okay, yeah. It's just being that way. This is on your homework a lot right here. I'm just going to write homework. It's on your homework a lot, this whole at least one thing. They're just going to go through the list and say, hey, at least one. And all of a sudden you're like, what do? You just one minus it. That's all. It's not hard. It's just you need to know what they're trying to ask for. Yeah. Out of 500. Yeah, exactly. So it says compute the probability that at least one male out of 500 will survive. So this is a little different here. And I think it's just the one. Oh, no, it's a little different. See, this is the probability of surviving, but now we're going to have to do the opposite to find like the dying. See how they said dying versus surviving? So it's like the opposite probability. And so what I did before anything, I did the 9986 and I subtracted it one minus that amount. So 1 minus the 9986 0014, and so that's our probability of dying. And now we're going to say at least one surviving kind of thing. So we're like doing the opposite again of that. So this is our new probability that we're going to use, but now we still have to use that formula 0014 now to the 500. Again, this comes up on the homework, and it's not, this part doesn't come up a whole ton. It's that just the at least one thing. Oh. Right. What's so interesting, just one, that's the answer. Think about it. It says compute a probability at least one male out of 500 will survive. Just think about this for a second, okay? You're saying, what's the probability out of 500 people? I just need one of them to survive. 100%. You know what I mean? What's the probability that like two of them are going to survive? Probably 100%. What about 400 of them? Probably. What about 450 of them? You get what I mean? Eventually, it starts to get dwindling down, but you're saying I just need one person out of 500 to survive. Are we talking like nuclear apocalypse here or something? It's weird. But there you go. Yeah. Is that okay? You'll see this thing, you do it, and we're done. And you can see we're done with that section. I want to go back to the homework now, especially for this one, because it's not hard, but I want to see where those things come, like especially from the homework. So here we go. That was 5. Is that 5.3? That was 5.3. Okay. Here we go. Let's just look around a little bit. Okay. It says, and what do we do? When you and, you what? You multiply. Wow. That was amazing. The word or, what do you do? Or. You add. Oh my gosh. It's like Chad knew what was going to happen. I did get a 100 on all this already. Oh, there's that disjoint. When two events are disjoint, they are also independent. Hold up. Let's go back. I said not necessarily independent. Did you see that? So I'm going to ask the question again. Are they independent? No. See, no common outcomes, but they could still be dependent on one another, I guess. So there you go. See how I knew that was coming up. You see that? That's why I do all these things for you. Anyways, I'm not going to go through all this stuff. There's a lot of multiple choice. I want to just, here we are. I love this one. It says, hey, we got this, we got that. What's the probability with and? What do I do with and again? What do I do with and? I multiply. You got it. I'm going to take those two numbers and multiply. Like, you can see the homework's not that bad. At least right now. We did it. Woo! Love multiplying, man. It's great. Great stuff there. Keep cruising. Okay. I think this is the same thing. You're just going to multiply again because the word and means multiply. We already did that in the workbook. Let's try this one. So it says, what's the probability? Oh, I know what to do here. The probability that it'll live to 3 years old is this much, 95%. So what's the probability that 2 of them are going to live to 3 years old? So this salamander is going to live, and that salamander is going to live. And means what? Multiply. But you can even do, to multiply faster, you could just do the power thingy. Now, notice it says 9. I'm sorry, not 9. 5 decimal places. That would have been crazy, 9 decimals. 5 decimals. What? Did I not type it in correctly? Ooh, I'm going to get upset if it's all being weird on me. Did I type this one wrong? Oh, look. That's a 4. Oh, that is so annoying. And then because it's off by just the tiniest bit. Oh, man. There we go. We did it. Okay, now it says 9 of them. What do I do? I change the power to what? 2 and 9. There it is. 6, 5, 1, 2, 1. Ba-dum, bum, 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 ba-dum. Easy stuff, right? See, if you know what you're doing, no problem. Keep cruising. Keep cruising. Oh, math phobic. Come on. They can't see your hands. Math phobic. Come on. Who's math phobic? 1, 2, 3. I have my own phobias, I ain't telling you. Okay? It ain't spiders, man. There's something else. It's even crazier than spiders. Even crazier than clowns. I'll see if it is that crazy with you later, but definitely not in the recording. So, 11% of the population says they have math phobia. If 2 people are randomly selected, what's going on? So, I select this person as math phobia and this person as math phobia. What do I do with and? I multiply. So 11 times 11. I get this number here. Now, I'm doing this one on purpose, okay? I'll show you why. Because right here it says that at least 1. You get what I'm saying with the at least 1 thing? So what do I do with this now? I do 1 minus that amount. Oh, y'all are coming back. So I'm going to do 1 minus. I think they're wanting to do 1 minus what I just had. I didn't really read the problem very well, but I just want to see what they say here. 1 minus, at least 1, none. Oh, I see. Okay, hold on. Give me a second here. I think what we're gonna have to do. Yeah. Okay, hold on. I'm making a mistake here, I think. Let me try this. No, I don't think I like this one either. That's the one I just had a second ago. Give me a second. I'm gonna remember as soon as I do it. I'm gonna remember. Here we go. What? Okay, hold on. It's 1 minus, but it's 1 minus whenever I do something else. Okay, if 2 people randomly selected, what's the probability of math phobic? Both of them. What's the probability at least 1? Assume they're independent. What was that formula again? Wasn't it like 1 minus, and that was it? Wasn't that it right here? Can I try something else? So I'm going to do 1 minus what I just had. Oops. Is that what they had? No? Probably at least 1 person is math phobic, and they're saying 20%. Are they saying like out of something else? I'm sorry. I know that I should just have the answer and everything, but do y'all ever get stuck on these kind of problems yourself? Be honest. And I even said, there's lots of this. It's tricky language. Watch out. I even said it right here. Right. Okay, so we got math phobia is the 11%. So then what if I did the 1 minus the 11 is it's 89. I bet that's what's going on here. So then if I did the 89 to, there it is. Man, so if you remember how this worked on the last problem, let's go back to the workbook for a second. Do you remember how on this one here I had to 1 minus the amount? And then I did the power thingy? That's what they're trying to say here. Okay, this is what they're trying to say. So the same formula, I guess, is that you have to, let me get rid of these top ones so that you're seeing it clearly here. I 1 minus the original amount. So I have the opposite, and that's what I do with the power thing with. Okay, can I do that one again? I'm going to do that again. Here we go. Oh, allergic to pollen. Look at that. And then look, it's the exact same thing. Let me just, give me a second here. Help me solve this, and I X out. Can I do? I just wanted different numbers. Okay, math phobia. It says, what's the probability that both two people are math phobia? So we got 6, and we're going to do the power 2 thing, and we're done. Did I not? Oh, not another 0. Okay. Are y'all okay with the both? You just multiply them, or you can do power 2. Are we cool with that? Okay. For the second part, what we have to do is subtract that 6% from our 100% to get the opposite. So I got the opposite now, the 94. So that's 94% of people are not math phobia. Okay? I'm going to take that number, and that's the number I'm going to use with this 1 minus formula thingy. 94 now to the power of 2. And there we go. I'm trying to show you the procedure. I mean, is there a different formula? Maybe, but this is the one that was in the workbook. Okay, so now you're seeing what I did. Can you replicate this for question 6 or whatever it is? Is it 6? I don't know. I was just, we're on to question 9. So on question 9, can you replicate what I did at this point and get through it? Okay. I get confused too. The language is tricky sometimes. And so I'm like, what are you trying to do here? Is that some multiple parts? What's the probability all 6? I can try it. Let's do it. So it says, what's the probability all 6 have danced in public while alcohol? What? Anyways, I'm not going to ask. I'm just going to do it. So we got 39, and then I'm going to power what? How many folks? How many folks are we talking here? 6. Very good. 0035. Okay, awesome. It says, what's the probability of at least one not dancing in public? Blah, 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 blah. This is that same thing. I need to do the opposite of the 39. So I'm going to do 1 minus the 39, so 61% for the not dancing. And then I'm going to do the 1 minus the 61. At least I think this is how it's going to work. We're going to check, okay? And then to the power of 6. And watch, I'm just going to get it all wrong again, I'm sure. Here we are. Of course. You hang on to that number, guys, okay? You hang on to that number, because guess what I'm going to try here? I'm going to try this 39 to the power of 6. Oh, man. It's tricky language, bro. See, I can get the numbers. Now, what's the probability that none... Oh, man. Okay, yeah. I got you. Okay. Time out for a second. We're going to do this 1 minus thing in a second. Y'all are okay with the first one, right? Power 6, we're done. Easy enough. And then it says, what's the probability of at least one? And it's the opposite already. Did you see how it says dance, not danced? Let me go back to the workbook again. And this is why the language is so weird. It says right here, blah, 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 at least one. And then all of a sudden there's none. It's like the opposite. So we have blah, 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 danced. What's the opposite of danced is not danced. Okay? So that's what we're trying to say. That little part right there changes everything so that you actually put it in like normal. Moving on. So it says, what's the probability in none? So I want to know, first off, what's the probability of not dancing? 61%. So I'm going to say you didn't dance, and you didn't dance, and you didn't dance, and you didn't dance. Nobody's dancing. 61. How many times? How many people we're talking here? 6. 1, 5. Okay. And then it says, what's the probability of at least one dancing? So we're doing the 1 minus thing again, yeah. Okay. 9, 4. And we had this number way earlier. Yep, there we go. So let's real quick just look at these two, because they're opposites to one another. Notice 5%, 95% essentially, right? So we're saying, what's the probability of none dancing? Nobody's dancing. What's the opposite of nobody's dancing? Is at least someone's dancing. See how they're opposites? But it's all like tied up in these languages here. I'm not perfect either. You can see that. I'm being recorded here. Did I get a 100 on the homework before class? Yes. Do I still make mistakes? Yes. It's okay. That's why we get through it together, right? Oh, that's just multiple choice. Oh, well, it's part 1 of 5. I'll let y'all figure that one out. So, yeah, I mean, it's not that bad. If it was bad, I would have told you. So, any questions? I'm going to move back to the workbook for a few minutes. We still got like at least 15 minutes. All right, conditional probability. This one's actually like, it's pretty easy. Again, multiply essentially. And then there's gonna be a keyword given here in a second. Okay, so let me go ahead and give you a little bit of chat overview. Are y'all coming back with me now? Is the workbook? Are we coming back? Back time for the workbook. Okay, here we go. So the main idea for this section is that given. There's a key word right here, given. And what that means is that it's already happened. Something else has already happened. Let me give you an example. What's the probability of me getting cookies on the way home? You're like, why would I get cookies? Because I got 3 little kids who like the cookies. So what's the probability? Let's say like 20%, okay? Because like I love them, but it's cookies. What's the probability of me getting cookies given that my wife calls me on the phone and says, hey, go buy them cookies? Now I'm definitely going to go get some cookies. You get what I'm saying? Something else has already happened, and it's changing what the probability is. Yeah? Yeah, I know, right? She called. Things are changing. Yes, things are changing now. What's the probability of you getting a flat tire going home? One way or the other. What's the probability of you getting a flat tire given that you drove through a construction zone? Maybe a little higher. Maybe what's the probability of you driving or getting a flat tire given that you drove next to something with a lot of nails? You know what I mean? So like it changes. Something else has happened. Now it's changing it. Anyways, so other than that, everything else is the same. So let's do the selected over total every single time. 2 cards are selected. Find the probability that the first card is a diamond. That's it. That just 1 card, diamond. So how many diamonds do we have in the deck? Do you remember? 13 selected. And how many are total? 52 total. Yep, 52 total. You'll see that the answer is kind of easy. Exactly. 1/4. Very good. Because what's the probability of a diamond? It's a 1/4 because there's like one suit out of 4 total suits. Okay. What's the probability that the second card is a diamond given that the first one was a diamond? Okay, now hold up. Pick a card, any card. Yeah. Whoop. And then what do you do with that card? You put it back in? No. You put it in your pocket. You hold on to it. You're not putting it back. I shuffle the deck. Pick a card, any card. So just the second one. So given that I already picked a diamond, pick a card, any card, got a diamond? Okay, cool. Now, pick a card, any card. How many diamonds are left in my hands? Not yours, mine. How many's left in the deck? 12. 12 are left in the deck because I already took one and put it to the side. How many total cards are in my deck? 51. Because I took one away, didn't I? See how that was tricky, right? You take one away, you throw it away, or you keep it on the side or put it in your pocket. What's left over is 51 cards now, and only 12 of them are diamonds. Oh, okay. 4 over 17. Okay. So starting over, find the probability of the first card is an ace. Pick a card, any card. What's the probability of an ace? How many aces we got? 4 aces. Total of what? 52. Once again, we're starting over. Yep, 1 over 13. Yep. Awesome. Now it says find the probability of the second card being a red king, given that you already pulled an ace. So you pull out an ace. Cool. Shuffle, shuffle, shuffle. Pick a card, any card. How many red kings are left in my deck? 2. Yep. We have the hearts and the diamonds. 2 red kings. How many total cards do I have, though? Go ahead. Yeah, the hearts and the diamonds. Yep, yep. How many total cards do I have, though? 51. Because I took that first one away, right? I said, I had 52, take 1, put it away. How many left? 51. Yep, very good. Good discussion, though. This is good. Well, I guess that's the answer. 2 out of 51. Can't reduce it down at all. So far, so good? Okay. Awesome. Cruising. Love it. Suppose that is this that one that confused the heck out of me? Okay, yeah. This one here confused me. I have it all down, but let me go through it, okay? Suppose that we got 12% of all births are preterm. Also, we have 0.22, very small, of all births resulted in preterm weight this much or more. So it says, what's the probability of weighing this much or more given that he's preterm? So, okay. I get confused about the language. This one was really weird for me. I had to go back up, and it was like right here, I think, that they were trying to do. Yeah, this is the formula. But look at how cryptic this formula is. So, yeah, and with all these words, man, it's crazy. So let me give you the Chad definition, okay? So this is what it is. Given is equal to and divided by regular. Okay, now I know that's not the best formula in the whole wide world, but let me try here. It says, what's the probability given? See, that's what they're asking for. And I've got 2 numbers, and I got to put one on top of the other, essentially. So notice that right here it says 22% of all births in a preterm baby are this much. They're saying that the baby's already preterm. Okay, so this is the and, would be my 0.22. And then the regular is just the guy at the top here, 12.7. Now you can like shift over to the decimals or whatever you want to do, but that's fine. We're just going to divide those two. 12.7. So then we get a small number, 0.173. And that's my probability. Go ahead. Right. That's kind of part of it. And I got to say that this language is not the best, but we're going to push through it. That's probably part of it. But right here, notice it says the 22. is resulting in a preterm baby, okay? They're already considered preterm, weighing this much. So they're saying they're preterm and they weigh this much or more. I'm tripping over my cable here. Preterm and this much. That's supposed to be an and right here. Did you see the word and? No, me neither. But this is what we're supposed to do. And I know that's really weird, but that's how it's going to look on the homework. So once you see this preterm baby thing, say that one more time. Oh, this is the answer. So it's essentially 1.73% is my answer, but they want a decimal form, 4 decimals and all that stuff. So this is, oh, it's right here. It's just, yeah, probability of preterm, period. Like no changes, nothing else, no givens, no ands, no nothing. Just probability of preterm baby, 12%. Yeah. It says out of 100, how many do you expect? So all I did was take my number. And what do I do with this guy in 100? I multiply. Very good. So I got 1.73. I don't know, 1.73 babies. I don't know. I don't know. Yeah. Yeah, basically 2 babies out of 100 will be preterm. That and no, given their preterm, that they also weigh a lot. Okay, there you go. I don't know. Yeah, I don't know either. Okay. Now you have the formula. And I'm hoping that you're seeing that I get confused too. It's okay. We're going to get through it, push through. And when we get to the next exam, which is a while from now, we'll focus in on the questions that they have. Y'all just took your test. Was it similar to the practice? Very similar to the practice. How about that pre-cal exam? We're not going to talk about it on recording. Anyways. Anyways. So we have another table here. It says, what's the probability of a child not having the gene? Gene not present. How many gene not presents? Yeah, the 30 is not present. 30 over, what's my total? Yep, you got it. Yeah, it might be the angle. I don't know. Yeah, it's about a fourth. It's pretty close. All right. So it says, what's the let me change my color on this one. What's the probability of not having the gene given that they have the normal IQ? So I'm going to look at this chart. I know that they already have a normal IQ. It's already happened. So a normal IQ, it means I get rid of this. It means I also get rid of this total because it means nothing as well. So I'm only looking right here. It said normal IQ. This is all I got left. What's the probability of not having a gene? How many people am I selecting? Not having the gene. How much do I have? 11 out of? There it is. See how I literally scratch through it? And this is what I don't recommend anymore, but you can do it if you use number 2 pencil in the lab. Or you can always use it on your own monitor. Yeah, what's up? Yes. So we know it's already happened. Yeah, we know for sure 100% normal IQ. That's done, and that way Everything else is completely aside. Now that I know that you're in this group, what's the probability? So like, yeah, it's just like I already know that this has happened, so I'm only looking right here. I'm trying to think of another example. Okay, so like we got males, females, own a car, don't own a car, right? So I'm saying out of the males, so I separate males, and that's what I'm looking at. That's it, right? Given that I'm looking at males, nobody else matters here. Now, what's the probability you owning a car, right? So like I'm trying to like just everything else is completely nullified. Brand new question. That's what the given means. Like that's another. Let's go back to the cookies for just a second. Me having a probability of going and getting cookies without someone telling me, that's one thing, right? But when my wife told me something, that changes everything. Do you see how I'm saying? That changes everything. My whole entire problem is completely resituated. Does it make sense? That old is discarded. When my wife says go get cookies, it's going to happen. It's a given. It's a given. I love that. That's funny. All right, cool. At least that's how I approach it. And you can see that I'm going to do that same thing here. It says blah, 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 probability of Navy. So how many do I have in the Navy? 35 out of the 96. You got it. 35 selected out of the 96 total. I mean, it's very simple to start with. 3, 6, 4, 5, 8, whatever they're going to want, of course. But that's not where they stop. They say, okay, what's the probability of the Navy given that we have female? I know for sure we're looking at female. So the males can leave the room, okay? And the totals don't mean anything anymore because they're just worthless totals now. So I'm looking at females only. What's the probability of Navy? What do I got? Out of? Perfect. 8 out of 24. Like they leave the room, where I get to re-ask the question. I get what you're saying though, I truly do. It's just a different wording. That is still a legitimate concept, just not what we're doing exactly here. Mm-hmm. Yep. 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 That's right. Go ahead. Actually, on this problem, I think they want the decimal. But yeah, typically they go back and forth between decimal and fraction. Be prepared either way. That's a great question. Yep, either way. Oh, it's good. Yeah, it's a straight up third. You're right. Okay, so it says, what's the probability of selecting 50-year-old or more from among those who are male? From among, that's a different way of saying given. So I'm saying, given that they're male, what's the probability of 50 years or old? Okay, so given they're male, all the females can leave the room, and then my total is also kind of meaningless. So 50 or older, what do we got? Yep, out of? Perfect. Perfect. I think that we're like done for the day, by the way. I'm just going to double check what's coming up next, but like we're running out of time here. Which is good. I think we got a lot of good stuff done today. No. Nope. Which is good because then I can just hang out with you guys if you want me to. Yeah, that's new stuff. Let's not do that right now. All right. Any questions? Are we cool here? Okay. I get confused too. That's the main takeaway, right? A lot of words. Kind of work through it. Thank you. Peace out, homies.